This is Season 5, Chapter 4 of the Tree of Life. In this episode, we will be talking about lateral action, as it pertains to joining or convergence of two distinct paths within nonlinearity. To start off, in Season 4, Chapter 8 and the past few seasons, we have talked about how lateral action is made possible by nonlinearity. In that, the many divergent paths created by an internet-mediated equilibrium. That is, an equilibrium of body homeostasis where oxytocin predominates, arising out of reciprocation, through the internet, and through lateral action. We also talked about how it is this potentiality for lateral action which makes it possible for the joining of two paths within nonlinearity. In this episode, I would like to elaborate how convergence, or the joining of two paths, is possible in this context. The joining of two paths arises out of genetic synchronicity occurring between two segregated, or independent social actors. In other words, since genetic synchronicity is a manifestation of acting on every impulse, with total commitment, and taking full responsibility for those impulses, i.e. the rules of nonlinearity, this reflects a close approximation of individual action to their underlying genotype as is possible. Since all human beings carry some common ancestral DNA from a common ancestor, this means that to some degree, this acting on genotype reflects a common heritage between two segregated individuals within distinct linear paths. Now, genetic synchronicity is the final part of the puzzle. The first part of the puzzle is reciprocation. Reciprocation causes a gradual shaping of a person's epigenetic heritage by oxytocin. This means that oxytocin release, and dopamine, is stimulated in response to reciprocation with some nonlinear actor. For example, let's say two people are in adjoining rooms in a hotel. Let's say they can hear the other talking, but only as a murmur. Let's say that one of them shouts something, then waits. Then shouts something, then waits. He does this for a while, until the shouting causes reciprocation in the adjoining room. The other person shouts. Now, this example is very concrete. But nonlinearity does not even require they be in separate rooms, or even in the same city. If person A reciprocates person B, in a particular way he receives a dopamine and oxytocin release. This means that there is a gradual shift in the reciprocating person's homeostatic equilibrium. This means that there will be alterations in epigenetic encoding corresponding to this equilibrium shift manifesting in the particular epigenetic machinery of expression. Now, what does this have to do with genetic synchronicity? Genetic synchronicity is as much about common heritage as it is about reciprocation. The gradual convergence of those two individuals' gene expression manifests as a common pathway arising out of genetic synchronicity. Let me explain this another way. Imagine that you have three doors in front of you. Each door corresponds to a particular epigenetic profile. Which is to say, that all three doors are possible, arising out of your genetics, but the choice of the one you go through is determined by your epigenetic heritage. Now, imagine for a second that you could change your epigenetic heritage depending upon who you spoke to before you entered that room. Now, imagine that each door represents a distinct linear path. Imagine that our intersections with others, by altering our gene expression, ultimately determine which door we go through. Where does this leave nonlinearity and lateral action? It means that within nonlinearity, imagine that all the doors become a single door instead of one. In this context, all paths are unified. Thus, the path you end up going through is the composite path. To the linear actor, the single path appears distinct from the path they are on, but to the nonlinear actor, all paths seem the same. From this we can see that the lateral action of the nonlinear actor only appears lateral to the actor who is within a linear timeline. And thus, it becomes possible to see that the convergence of those two actors follows from the gradual convergence of the epigenetic profiles pursuant to expression. Finally, we can see from this that the genetic synchronicity, which generates convergence of these two linear streams, is a product of a common trait representation between each actor to each gene. In other words, the internal to the external synchronicity is common. A common internal pathway reflects a common external one. That's the end of the podcast for today.